So let's start with an overview of really the main idea in the course. So this is what we're going to spend most of our time with. So let's look at that main idea first. And I'm going to start with actually continuous data. So let's think of two variables. Maybe it's something as simple as height and weight. Okay, so I have two variables, and we look at height and weight, and so those are height and weight. And when I look at those, I could go out and collect a bunch of data. Now, these are some of the sub-ideas of how do I collect good data, and what am I really asking, and so forth. But here I probably just want to ask our simple question for most of the things that we care about in this course is that simple question is, does height have any relationship to weight, or vice versa? Does weight have any relationship to height? And I'm not talking about causing there. Let's be careful also with a word that people like to throw around, correlation. That's actually a very technical word. And so I'm not going to ask at this point in time, are these two variables correlated? I'm going to ask, is there a relationship between them? One way to think about it is, could I predict weight from height, or could I predict height from weight, that sort of thing. So prediction is one way to look at the basic idea is, if I can predict, okay, so if I can predict, in other words, if I know something about height, if that helps me with a person's weight, or vice versa, if I know something about weight, if that helps me with a person's height, then I'm saying I can use it to help me predict. Now, I may not be great at predicting, but somehow I can use it. So if I can predict, say, weight from height, then what I say is there is a dependency. And we'll see, we have to be really careful about this, but that's, in many experiments, that's what we're looking for. We're looking for this dependency. If not, then they are independent. And this is where it becomes hard, because, are they dependent or independent? Where it becomes hard is with real data is, where do I decide? How do I decide if I can predict or not? So let's just take something like this, and we're saying, can I predict weight from height? And so, in other words, does height explain weight? And so this is our response. You give me a height, I will respond with a predicted weight. Right? So the height explains the weight, and the weight is the response, because you tell me a height and I will predict a weight. Now, so I go out and I collect data, and suppose that data kind of makes this cloud. Now, what I see is, if you told me some height, like right here, well, I would probably predict a weight between those two numbers. I might pick the middle of that, the median or the mean or something like that. But I would predict something between those two numbers. Now, if you gave me a height up here, I would predict something between those two numbers. So you see, my prediction does change. If I have a very low height, then I predict something in this lower weight. Now, there's a lot of overlap here, but it does appear that maybe height does predict weight. And certainly, that's to at least some extent true. If you tell me somebody is 4'5", and if I were to predict, say, 90 pounds, I don't think anybody would look at me really strangely. But if they were 6'5", and I predicted 90 pounds, you would look at me very strangely. So certainly we know that there's at least some predictive ability there from height, but how much, I don't know. I don't have the actual data. But what we're looking for is, if I have these two continuous variables, I'm kind of looking for a point cloud that tips. So in this case, it seems to be going up. The point cloud is basically going up like that, but it'd be okay if it went down this way as well. Either one. But if it tips, then you see my prediction changes. As I move along the x-axis, if my point cloud tips either up or down, my prediction is going to change as I move along that axis. It'll either go up like this, or it will go down like this, but it does one of the two. And so with a point cloud of these two continuous variables, that's all we're looking for, is sort of that tendency to tip one direction or the other. Now, we're actually going to start off, instead of with these continuous things, we're going to start off with, but I'm going to go ahead and put a few points in here like this. We're going to start off with what we call categorical ideas. Well, I can turn the heights and weights into categories very simply. And so I think it's very important that you realize that as we do these different tests, they're really all looking at sort of the same idea. So suppose I take the height and I categorize it, I don't know, let's just go with shorter, medium, and taller. And so I'm going to say that anything in here is shorter, anything in here is medium, and anything in here is taller. And, I might look at the weight up here as, I categorize anything down here is underweight, anything in here is maybe at weight, and anything up here is overweight. And now, notice that I've got this categorized. Well, instead of showing you every single data point, what I could do is I could come over here and I could make a table, overweight, at weight, underweight, and I fill those in, and then now typically with a table you'd probably see the headings instead of at the bottom, at the top. So here it's shorter, medium, and taller. And what I could do is count from my data how many things and how many data points show up in here. And so for this data set, well, it looks like 0. O is a bad thing here, but because it looks like a 0, but 0 there, it looks like 0 there. As I count this, I see 1 thing in there. It looks like maybe I've got 3 there, 1 there, 3 up here, 1, 2, 3, 4, 5, 6, I don't know, we'll say there's 7 in there, maybe 3 or 4 in there, and there were maybe 5 up there, I don't know. Now, so as you look at this, though, as you look at these numbers, notice they end up reflecting the same thing we saw over in the dots over here, is that we see a point cloud that goes up as we move to the right. And so here are the data, and notice that I see that not so many things here on these two diagonal pieces, upper left and lower right, and more things toward the middle, and and definitely more things along this line here. And so you see in our data we see that same exact trend. And so we're going to start off with count data, but you see count data in many ways if my categories really came from numerical data to begin with. Now, most of our categories won't, but if they did, you see we can actually see that these two representations are really showing us the same thing. Okay, so as we start looking at count data at this stuff over on the right, we're going to ask, sort of, is there some kind of trend that we could see? Now, you can also get predictive quality without a relationship that's just tipped. So, for instance, here, if I had data like this, I'll keep height and weight, although this would make very little sense to me. If I had that, this still has a great predictive quality. And in this case, right, the trend is not, something like this or something going the opposite direction, top left to bottom right. It is what I would call a nonlinear relationship. It's not a straight line, it's going like that. Well, again, if I made my table here and tried to reflect my count, notice it looks like I've got 0 here and a whole bunch. So a whole bunch, I don't know, that's like 17, right? That's a whole bunch. 13, 15, 16, 15, something like that, and maybe there were just 2 there and just 3 or 5 there. But you see, again, in the table, I can see the numbers that if I were to put a bunch of dots in there, I would still say the trend looks like this. So we're going to look at ways to decide whether there actually is some sort of trend or predictive quality between these two variables. Now notice this is still height and weight. Those are the variables, but the categories also take on names. Whereas over in the continuous stuff we talked about just numbers, and we don't really think of numbers as categories, and they aren't. But we can put those numbers into categories by their size, and or we could put categories like even and odd and things like that. So we're gonna start with categories, and we'll have a variable, say weight, at different types of categories, different levels or different categories within that categorical variable. But as we look at a table, we're going to look at whether that table appears to have some predictive quality about it, or if I have a table like this, I'll just make it a 2x2 table, and suppose there are 5 things there, 5 things there, 10 things there, 10 things there. There's really no predictive quality for one variable versus another, right? If you tell me this variable that's going up and down, I'm in the top row, well, it looks like there's a 50-50 chance to be in either column. But if you tell me I'm in the bottom row, it still looks like a 50-50 chance. And so in this case, you see there's no predictive quality, and so I would call these dependent. Whereas up here in this one above us, there appeared to be a predictive quality. If you tell me I'm in the bottom row, I am definitely not going to predict something in the middle. But if you tell me I'm in the top row, I am going to predict something in the middle. So you see, I changed my prediction. There's some sort of predictive quality. That is what we're going to look at in the course, is just trying to decide from our data, is there a predictive quality going on here that we can work with or identify, or not? And that's our big question. For a semester's worth of work, we just want to answer that question. Here are two variables. Is there some sort of predictive quality within those variables, a predictive relationship, or not? Either answer is okay. We just want to use statistics to help us decide that answer. So that's what we're doing in this class.